Hey folks, look at that. Just a short break and already we're into our next talk. And our next talk is going to be a fun one. It's actually my pleasure, my privilege to introduce you to Eran. Eran is here to talk to us about optimizing software logging costs. And I'm sure there's a much more magical way you can describe it than I can ever do it justice, which is why I'm now going to pass you across to Eran. Reminder, folks, we will have some questions and answers towards the end. So if there's anything along the way that sparks your intrigue that you want to know more about, pop it in there and I'll relay it to Eran at the end.
Thank you. Thank you so much. I'll get started. I'll just share the full screen so you can see it wide. My name is Eran Kinsbruner. I work for Lightran. Lightran is a debugging troubleshooting platform for complex architecture in production and actually any running live applications. And as mentioned earlier, I'm going to talk to you today about multiple challenges with complex architectures and why these challenges are actually occurring to developers and what they can do about it to overcome them. And at the end of the day, especially in the current economic downturn, what does it do and how can you improve the bottom line? Because developing software costs money, we know that, and developing in cloud or cloud native applications cost even more money. So looking at logging costs, looking at how we can improve developer productivity, reducing MTTR. I know that any developer who at least worked 1 year in the industry have heard these slogans of MTTR, dev productivity engineering. So I'm not going to talk to you about slogans. I'm actually going to talk to you about practice and practical tips and advices on how you can actually impact your bottom line, how you can overcome some of these complex challenges. So let's get started with the main pain, okay? As things shifted from monolithic to microservices, shifting towards agile and DevOps and trying to kind of meet this iterative release cycles that everyone is dealing with for the past decade. This is nothing new. But what's new is that, up until quite recently, and I will try to convince you that things are changing. These dev and ops were, even though it's one word in many things, in many terms, the reality and the way things are working today, there is kind of a disconnect between developers and operations. And this connection is around skill set and also around the tools that these two personas are using, even though they are working together towards the same goal of delivering fast and with high quality. But when things are broken in production, the ops guys get alerted and they have these different tools that they're using, right? They're using Datadog and Splunk and many other great tools to try and pinpoint the root cause of the issues. And while they are not the ones that wrote the code that is either causing outage or other performance related degradations, they relied back then on the developers, which are actually using a different set of tools. And by the way, they are not really having the great access to this production runtime environment. So this huge pain leads to unsuitable existing tools, right? Again, different tools for different personas. Static and iterative and non-agile process. And what does it mean? When things are broken, you need to stop what you're doing and you need to either deploy new log lines and new telemetry into the production environment, which we know requires a restart, a redeployment of the CI/CD pipeline, additional testing to make sure that you added logs which didn't break any other things that are running right now. And if there is, it's in different time zones, God knows, how you deal with that. So all of these processes to accommodate the reality of dev and ops working together across different tools, causes a lot of bottlenecks, a lot of pains, and at the end of the day, many developers are kind of putting a lot of safety nets in the form of logging everything and analyzing later just in case, right? So they're putting a lot of log lines just if something crashes in production, just if something is broken, they will be as ready as they can. But at the end of the day, it's again inefficient and it does not really connect to the operational guys that are looking at different tools, at different dashboards, and sometimes they do not really know how to overcome these kind of things. So that's one of the pains. But let's be a bit more specific and look at specific use cases, because as I mentioned, putting aside use case number 3, the majority of applications today, are microservices or serverless. We're looking at containerized applications and very advanced technologies. And at the end of the day, these technologies are built from an agile and DevOps perspective, from a high-performing, high-scale set of applications. So the goal in mind is really good, right? You want to provide short, quick values with microservices to your end users. But once you're dealing with Kubernetes and containerized applications, serverless like Lambda, and other types of serverless application, we'll touch on that very soon, you are also dealing with challenges. Keep in mind that we also still deal with legacy and monolithic applications. For those of you who are following me, last week I did a nice webinar with M&T Bank and Bank of Montreal, BMO, and these guys talked about a museum of technologies, because in an enterprise bank like they have a mix of legacy monolithic applications, which are very heavy to maintain, built on very old and unmaintained source code, and the deployment or the cycle to release a new version under these constraints is very long. But they also have more modern types of applications, including cloud native applications and the likes. So think about an organization, an enterprise organization that has multiple types of applications, including legacy and cloud native. Then we deal with CV prioritization. What is CV prioritization? CV prioritization, when you're dealing with security, right? Static software composition analysis, when you're dealing with open source libraries, you're getting dashboards from Snyk and other JFrog and other security tools, but you see a long list of vulnerabilities under the name of CVEs, and these CVEs can take a lot of time and resources to deal with if you cannot properly prioritize them. And I will talk a bit about how to prioritize these kind of things to, again, impact the bottom line, impact the productivity, and deal with the right things in the right order. Code flow investigation and feature flags, we will deal with that as well. It's another use case that takes a lot of money and time, and it's a huge challenge, especially when you're dealing with microservices, cloud native, and complex architectures. Log optimization, I will talk about it as well. CI/CD debugging and debugging within a running pipeline, how you deal with that in a cost-efficient way. And lastly, how you use what we call the better together approach. How do you use dynamic observability solutions with or in conjunction with performance and APM tools like Dynatrace, Chronosphere, and the likes? So there are a lot of troubleshooting issues and challenges, and I've just decided to focus on these 8, okay, in light of the previous slide of connecting dev and ops, or connecting developers to the live running applications. So let's try and understand one by one, why is this so challenging? Okay, anyone who is building today an application that is deployed in Kubernetes, in AWS EKS clusters, knows that being able to troubleshoot within this infrastructure and architecture is a huge pain. Why? Because these services, these applications, or subset of the applications are deployed across multiple pods. Sometimes it can be dozens, sometimes it can be hundreds of pods. And getting access from your development environment to a pod running deployed in production, the developer doesn't always even know where it's being executed and deployed. So getting the access and reproducing the issue, that's one challenge in Kubernetes. The other one, getting the remote access to specific production environment from a security standpoint. I'm not just talking about the technology side of the house. I'm talking about the simple access, which ops might not even allow developers. Sometimes, of course, they are right? So getting access to this production environment is not always allowed or approved by the organization. Think about an enterprise bank and stuff like that. And obviously, making changes in production and stopping things is also something that no one really wants to deal with. And lastly, getting or requiring IT and the admin and the security to do a port forwarding for these specific applications or deployments is not always approved. So troubleshooting when something goes wrong, when you have a Kubernetes cluster running your application or multiple replicas of your applications across multiple ports, that's a huge challenge. And these are just a subset of the reasons. Okay, so that's one use case which we are seeing today and becomes more and more time consuming, expensive, and very challenging for developers. Second, the big brother or the modern brother of the Kubernetes is obviously the serverless. And the serverless architectures, either AWS Lambda or Google Cloud Functions or Azure Functions, these types of task-related architecture is becoming a modern architecture by many organizations that are trying to shift to a more cost-efficient way, because when you're dealing with serverless, okay, you don't need to deal with the servers and the architecture and the hardware. You get this being managed and produced to you or delivered to you by the cloud providers. But the lifespan of a serverless function like Lambda or Google Cloud Function is short. So being able to troubleshoot in such a small window, reducing cold starts, reproducing this kind of crash or issue sometimes takes a lot of technical skills, environmental challenges to overcome, and it's not something that we are seeing mature processes and practices led by developers. So troubleshooting, if I wasn't convincing enough in troubleshooting within a Kubernetes cluster and a Kubernetes architecture, double down on that towards serverless architecture, which is a very kind of agile on steroids way of developing applications. And you see here more examples like determining the resources that are being used by the serverless architecture and so on and so forth. So that's another huge and complicated challenge I'm seeing for my customers at Lightrun, dealing with a span of 1 minute, 2 minutes, 5 minutes of a function that's running your subset of the application or the service, trying to deal with this short time window that you have to just troubleshoot, get a log, get a snapshot from what's going on there. It's a huge challenge. Another one, and I talked about it earlier, I'll just breeze through that. We talked about the Museum of Technologies that is still a reality in healthcare industries, in the financial industries, right? You are dealing with code that you haven't written, a lot of legacy code, and a lot of unmaintained code, undocumented code, code that does not have logs at all. Okay, which means that if you want to add logs to a legacy application running either in production or in staging, you need to add new code and you need to build the entire monolithic thing, which takes a lot of time and impacts your overall productivity. You want to make sure that you are dealing with a state recovery of these kind of huge applications. And these monolithic applications also have tons of dependencies on databases, libraries, and so on and so forth. So replicating everything and recreating them just to troubleshoot, takes a lot of time. And basically time is what we don't have as developers. So that's another third huge challenge that we are seeing and hearing a lot day in and day out. And obviously it depends on the vertical, the market segment, again, healthcare, financial and insurance industries, and others that are still, mixing between modern architectures like serverless and cloud native applications and monolithic. So dealing with these kind of things is, again, a huge challenge on developer, which costs time and money. I mentioned a bit about security prioritization. As I promised, I will double down on that. So a lot of tools today, or a lot of organizations, including Lightrun, my developers are running upon their CI/CD as part of the definition of done. There are many terms to that. When they are releasing a new build, they are also doing a scan of the code, especially on the third-party open source libraries, and they are using tools, SCA tools, and I mentioned just a few of them. And these tools are creating what we call SBOM, right? And that's a list of vulnerabilities coming, and just anyone that is listening to the news over the past year or so heard about the logs4j, log4shell, and there were other major things also around Python libraries that were detected by SCA tools. So how do you know as a developer, especially if you're using progressive delivery and feature flagging, which users, in which execution path, in which flows, you know, this vulnerability even exists? Because just trying to solve dozens of red flags coming from SCA tools, which are not even executed in production by your users, is a waste of your time, a waste of your efforts. And by the way, it might even introduce new bugs which you didn't intended to do. So being able to properly prioritize these CVEs goes a long way to reduce your costs and increase your developer productivity. But for that, you need to understand your code path, your execution path. You need, as a developer, to put what we call breakpoints or snapshots, get dynamic logs in runtime, so you understand that when you're putting a conditional log for this CVE and it's not being hit, it's not being caught, it means that you are not impacted or affected by this vulnerability. Progressive delivery and feature flag, I talked a bit about it earlier. It's something that is becoming very, very wide, especially with DevOps and Agile. You want to do kind of A/B testing. You want to just test the water with a gradual exposure of a feature, of a segment of your database, of your users. But to make sure that you're gaining the confidence in production in this small segment of users and exposure, you need to be able to easily replicate this environment, easily get feedback from these environments and feature flags. And it's not easy, okay, especially as a developer, to get feature flags in production and getting insights, logs, snapshot, metrics, traces. This is not easy to do, and this is, again, something that causes a lot of pains and challenges. I talked a bit about cost, and that's kind of even in the title of this presentation. In the recent FinOps, State of FinOps, FinOps, by the way, for those of you who are not familiar, FinOps is a subset of the Linux Foundation, and they are growing. I am a FinOps practitioner myself, and I contribute to the working groups in FinOps because their entire goal is to reduce the overall cost of cloud computing. They do so by shifting FinOps towards the developers, embracing best practices, and educating developers so they are more accountable, more aware to the terms of sharing costs, okay? Cost allocation, being in the know of the bills that are coming from the cloud providers, so they can think ahead where they can save more money when they are adding new logs, when they are using more cloud services. We talked earlier about serverless and Kubernetes clusters and stuff like that. So how can you be more efficient? So being able to analyze the cloud resources, getting the bills in front of the developers and shifting responsibility left is something that can help in reducing the overall cost. Specifically in this session, I'm referring to how you can reduce the amount of static logs, logs that are inefficient, logs that are not even being used ever, and you're just piling them and paying to log providers and cloud providers. So this is at least one item out of many that you can, as a developer, know, be aware of, and chase to reduce your overall cloud bills. Within CI/CD, and in the past I used to lead a lot of quality organizations. Being able to understand why CI/CD is breaking, why it's failing, which test is causing that, again, requires pinpointing the issues, being able to observe your entire pipeline and get the insights while the build is running, not stopping it and starting it again. Think about the previous slides that I talked about. These things are very costly and very time consuming when you're trying to just add more logs to debug, and you need to rebuild everything and replicate the environment, it takes a lot of time. So challenges around CI/CD and debugging are exactly around that. Replicating issues that are failing in your Jenkins builds or GitHub Actions and stuff like that, getting the right observability in the right line of code in the method that you need is something that you can use as a developer to optimize everything that you are doing. And when you're doing that within your native debuggers with the IDEs, obviously they cannot reach this level and depth of observability. Hence, you need something which is called dynamic observability, debugging in production, debugging within running and runtime applications. Lastly, performance, and user experience, and how better together. I gave a hint in the previous speech earlier in this session, and APMs are not really using the code. They're just showing you dashboards, showing you snippets, and they're not touching the runtime applications. They're showing you something that happened and giving you the alerts. To being able to pinpoint, spot, put logs, and understand the root cause of a performance degradation or a crash or an outage, etc., you need dynamic observability hand in hand with the APM tools, so you can really get as a developer whatever you need. Because developers, I will tell you that developers are not performance engineers. Okay, they are great in developing, writing code. When it comes to troubleshooting performance issues, especially in microservices, serverless, and other complex architectures, it's a bit more complicated, and APM tools are doing a great job up until a certain point, and they need to be complemented by additional tools and layers of observability. So how do I approach that, and how do Lightrun looks at that? Lightrun looks at that as I mentioned many times in this presentation, dynamic observability. Let's call it even wider, because there were so many DDs in the past, right? Behavior-driven development, test-driven development. Let's use another one called observability-driven development, meaning developers getting more accountable and getting more tools and capabilities to troubleshoot runtime applications. And what does it mean? Giving the developers the ability from their native IDEs, IntelliJ, PyCharm, VS Code, all the environments that they're working with, because the developers are not working in Dynatrace, the developers are not working in Datadog and the other APM tools and providers. They are doing a great job, but they are on the right hand, okay? The developers are, at the end of the day, living within the source code, within the IDE, and they need to operate and troubleshoot issues from their IDEs. They need to do it in real time, in production, and not deal with recreation of environments, dealing with security, CISOs and others that need to give them permissions, or the ops guys that need to give them permissions to touch sensitive things in running environments with customers. And they, again, need to be cost aware, especially in today's reality where the economic isn't great, understatement. So you need to be cost efficient and aware to that. So giving the developers the accountability, the awareness, and the tools to troubleshoot in production across these multiple use cases, I just gave a subset, there are obviously more, is key for developer productivity, for cost effectiveness. And how they do it? By dynamic observability, by observability-driven development. When they are doing it properly, these are a few of the things that they can obtain. And I have many customers, and by the way, don't take just my word. If you go to lightrun.com, you can look at some case studies that customers wrote with their names, okay? How, when they implement observability-driven development, how they use dynamic observability with debugging in production, they obtain all these 6 benefits, okay, of MTTR being reduced, quality of their applications is rising, time to market, developers are much more happy and productive because they don't need to context switch and talk with different personas within the organization. They own their code, they built it, they own it. And the way Lightrun is doing that, okay, I will soon jump to a short demo to show you, so you believe me that I'm not bullshitting anyone. Lightrun connects from the developer environment, the IDE, IntelliJ, VS Code, and others across multiple runtimes to the running applications, whether they're in production, in staging, CI, dev, QA, whatever application wherever it's being deployed, in what has many pods or serverless architectures it's being deployed, the developer can access this deployment in a secure channel in read-only mode to put snapshots, logs, and metrics so we can understand what's going on with the application. And just to show you that I'm not inventing anything, you can see what's going on here on my screen. Okay, that's a very simple application in Java, which goes to wikipedia.com, goes to the Wikipedia page and polls for a random Wikipedia article every half a second. Okay, so this is in my native IDE, that's in my IntelliJ. But what I'm going to show you right now, what I've done prior to this session, okay, I've deployed the exact same application into two different environments. Okay, one runs on an AWS virtual machine, remote. Okay, it's deployed in a remote virtual machine, and another one is in an Oracle environment. And what I'm going to do right now, I'm going to run the application, the Java application, both on an AWS remote environment and on an Oracle environment. And you can see that this application is running with a Lightrun agent attached to this. That's the only thing I do, okay? The application is running, and you see it skips every half a second. It gets a new article from Wikipedia. You see it here in the command prompt. The exact application here is in my IDE, in my local IDE, and you see right now beforehand, I don't know if you spotted, okay, there were no agents running. Right now you see that I have two agents that are running, one on AWS and one on Oracle. What I'm going to do right now, I'm going to put a conditional log, okay, or just a log on both Oracle and AWS, and I want to get into my console from the live running application in production the articles, and I'm putting here Wikipedia article is, and I'm taking the parameter, and you soon see from Oracle, okay, brace yourself, you will see here in the log, okay, that's the Lightrun console, sorry, I closed it, okay, you will see Wikipedia article, it's running, you see the time right now, okay, that's the day, that's the time, and this is these are the articles, and I'm piping them both to the Lightrun console, but also to, sorry, to the stdr. So you can see it here, Wikipedia article is. This is the Oracle VM, which I'm injecting, inserting logs, so I can really understand what's going on in this specific line of code. And that's how I would put dynamic logs. I don't need to deploy the application. I don't need to change its state. I don't need to redeploy anything, okay? And what I can also do, okay, if I want to just stop and take a snapshot, again, without really stopping the application, I can take a snapshot of the application. And you see here, a snapshot was taken directly from production, okay? And I can look here at the entire stack trace of the code and look at what's going on. So let's stop for now. We have deployed a running application in Java into two remote distributed environments. They can be Kubernetes, can be serverless, whatever, okay? And as a developer, I don't really care where the application is deployed. What I care about is that someone told me that in this Wikipedia application, I have a bug, I want to troubleshoot it. I immediately go, I didn't have any log lines in this code, so I'm adding a dynamic log. It's free, I don't need to stop, I don't need permissions to run a CI/CD and build and compile and test. I'm just adding the log, it's read-only, so I'm getting the insights into my IDE, and I can fix the issues, and if needed, I will redeploy a fix. I get a full stack trace, and if I need it, I can also put some metrics here and measure how much time it takes to run the entire code block. So that's from a dynamic observability standpoint. But what I also told you earlier is that today, and by the way, you see it here also in my PyCharm, okay, because that's my agent. What I also wanted to talk to you about is the cost of logging, because as you saw in the demo, it's very connected, okay? I debugged this Wikipedia demo without any static logs that were in the code. I added logs when I needed them, where I needed them, and I was able to troubleshoot the issues. But I want to make sure that, as I mentioned earlier, we have a lot of dependencies, we have a lot of legacy code and third-party code coming from open source. So I went ahead and took, it's very timely, a ChatGPT workspace from or repository from GitHub, and I wanted to see, okay, it's not a huge project, so I'm not expecting a lot of waste here, but I wanted to measure if there is any waste of log lines that aren't efficient at all. So what I've done, I've just cloned the repository, added it here into my PyCharm. It's written in Python, and within the Lighten log optimizer, I'm going to scan the project. I can scan a single file, but I can also scan the entire project. And this requires Docker to run, so Docker is running in my background, but I'm scanning this Python project, and I want to see if there is any waste, if there are any log lines that are not producing any value. And surprisingly, there are 4, it's not a lot, but still 4 log lines that if by any need I will have an issue with this area in the code that I will need to troubleshoot, this is going to cost me money because these logs are useless. Why? In this line 304, and I can go directly to the line by clicking on this link, the method of single query has a marker log line in the beginning of the method. What is a marker log? Marker log just mentioned to the developer or gives the developer an indication that the execution of the code reached this specific line. It has nothing to do with debugging. It cannot really do anything about it. Okay, method init contains log instruction with a static message. Again, 0 value here, and it goes on and on. I scanned, by the way, the Spring Boot application prior to this session in Java. I got 549 or something log lines that were of waste. So think about what we have discussed in the beginning of this session. We talked a bit about log optimization. We talked a bit about MTTR and dev productivity and cost optimization, and this is exactly why we need to care about that. So let me just stop sharing and reshare again my screen, because when I moved to the IntelliJ, it stopped my ability to present. So I will soon wrap up the session, but I wanted again to show you live, how you can really tackle feature flagging. Because think about the demo that I've just gave you with Wikipedia. If you had an issue in a segment of these deployments of the Wikipedia, only in a different geography, only with a feature flag, exactly with conditional logs, with snapshot, you can understand, you can gain observability and pinpoint what's going on in your environment. So let's wrap up what we have talked about up until now. We talked about use cases in troubleshooting complex architectures. We talked about Kubernetes, serverless. We looked at a bit about the challenges with CI/CD debugging, CVE prioritization, security prioritization. We talked about legacy and monolithic applications. We talked a bit about feature flags, and then we talked about logs optimization, how you can reduce the cost of logging to be a bit more productive. We touched a bit, I think, into 8 use cases which developers today are challenged with when it comes with debugging in real time, in production environments, in complex architectures. We have looked at 2 demos. One of them was featuring a remote deployment debugging in production. We didn't need to change the state. I didn't need to talk with the ops guys or redeploy anything into the Java project just to get logs and metrics or snapshots, which is called live breakpoints. And then we looked into the log optimization. We looked at what FinOps is trying to pitch to the entire world today. Cloud computing is becoming extremely expensive on developers, ops, and IT management. And this is where things need to change. And it changes with workflows. It changes with process. It changes with visibility and accountability into why we're spending X amount of dollars each month to the cloud providers. No one is taking away the cloud vendors. They are great. We worked close with all the cloud vendors. But still, as a developer, we need to be more context aware. We need to be more budget aware into what we are spending, where we are spending, when we are spending, and how much we are spending from a scaling perspective. And if we do so, we can actually gain this money back to be more productive. We can spend this money on more innovation and more optimization of our code and stuff like that, rather than just spending things like static logs and other inefficiencies. So we looked at log optimization and remote deploy debugging. I didn't show you the GitHub action demo with .NET. Believe me, it's ready, but I will be conscious of the time here and leave some time for Q&A if you have. But with that, I want to leave time for any questions that you might have. And regardless, appreciate your attention, your time. If you want a copy of these slides or have any questions that you want to ask me in private, I'm also available on the DevOps Europe event Slack channel, so you can get in touch with me. And if you want to get or give a try to Lightrun, it's free. You have a free trial that you can use for any runtime, Java, Python, Node.js, and .NET. So you can go ahead to lightrun.com and do the free trial and see how it can help you. And with that, I would like to hand it over to you, my dear moderator, and see if we have any interesting questions or challenges that I can address.
Yeah, thank you very much, Eran. Yeah, if you guys do have questions, drop them in the Q&A tab, and I will relay them across to our speaker. Really interesting discussion there, and I love the kind of focus on this kind of self-awareness, right, that you were kind of highlighting, right? Like being aware, choosing to be more efficient. I think one of the big kind of things that I want to ask you is, with the way you kind of describe the cloud, the way it's been utilized right now, do you think that a lot of people have become kind of reliant on the cloud as part of their product, and in a lot of cases they're maybe just using it for the sake of using it?
You said it exactly right. And if you go to the, by the way, next month, I'm heading to San Diego. There is the FinOps X. So FinOps X is the annual conference for FinOps. We're going to have tens and thousands of attendees over there. And I will surprise you. The partners or the vendors that are driving FinOps are also some of the cloud providers themselves, Google and Microsoft and AWS. So everyone understands that cloud is running the world today. Everyone relies on the cloud. But to your point, they should not rely on the cloud just for the sake of the cloud. They should rely on the cloud because of the power that it gives them, the computing power, the agility, the scale, the reliability, and the performance. So there are a lot of benefits of the cloud. No one will ever take them. But especially, again, in the current economics, we all, it's not just the developers, even though that's a developer conference now, everyone needs to understand why and how and where they're spending their budgets so they can improve.
Yeah, I think the scary part as well is like you then end up, it's not just a case of people just being in the habit using the cloud. Then you create kind of a second layer to it, right? A kind of self-fulfilling prophecy where people are creating apps and automated tools that realistically don't even need to run on the cloud, but they're designed to do so. And then people become comfortable using them, right? And it just keeps feeding the beast.
I like the word the beast. Yes, I've seen some builds and samples from the FinOps team. It's millions and sometimes even more a month just to feed and to support your ongoing. Sometimes it's just adventures, okay? Sometimes because we got used to paying this amount of funds. We just keep on doing that, right? And that's not a recommended practice.
Yeah, it's kind of a weird, scary direction to take. And it started off just being enabled by, great discounts, right? It's the classic one, you buy in cheap and all of a sudden you become reliant. By the time you realize the prices have gotten out of control, you are essentially like addicted. I don't, addicted maybe not the way, but you are essentially addicted to it, right? You've got the drip for cloud sources in your veins.
You're
One
tied.
thing,
You're tied. It's not. You're just tied to this
yeah,
workflow and process. And there are a lot of even. It comes not just from the developers. It's also from the product management, right? Product management builds new features, and these features rely on the cloud itself. But you need to optimize as you develop. So hopefully, I envision that in the next couple of years, maybe not too long, you will see kind of a FinOps in the definition of done. You see a FinOps metrics, set of metrics being added into the story points, into everything that we are building. So the developers start to understand, okay, I'm building this feature is running on AWS, and it's going to cost me X, my budget is Y. Let's see how I can deal with this discrepancy. Maybe we have a shared pool of resources on AWS that I can utilize and use as part of my feature development and ongoing maintenance and activities. So that's, I think, how things are going to evolve, because people are not going to continue paying this amount of sums to Datadog. And again, I have nothing against Datadog, but to the cloud providers, to the log storage vendors, because it just piles up and it's inefficient. That's all.
Yeah, and you mentioned the project managers. I think that's an interesting one to kind of pivot into. Is like earlier on in the presentation, you were talking about this idea of shift left observability, right? Of empowering the developers. Now, maybe it's the skeptical person in me, but the moment that I heard that, I thought, oh, there's going to be resistance from people up top, right? There's going to the project managers, the people above. There's a desire to have that layer of control and always being able to check and understand. So, how would you, with this new kind of philosophy, address that? Right? What would you do to convince them of this new movement?
So I have 3 examples, and I'll be short. First one, almost a decade ago, I started using a term called continuous testing. Okay, back then people say, okay, you're just talking about agile testing. I said, no, continuous testing is different, because it also involves the developer and devs. I even wrote a book about it. It's listed very high in the DevOps world as a great book. Then came things like TDD and BDD. People say, okay, why would the developer write the test before he writes the line of code? It makes no sense. And TDD became a thing. It became a practice. So I gave this ODD. I'm just kidding. It's growing, but let's try and talk in a few years and see if this observability-driven development, shifting the power and the observability to the developers. Again, as I showed in the demo, I am not risking anything in production by allowing developers to get logs and snapshots from production. He's doing it from his local IDE, okay, in a read-only mode. He cannot touch the code running in production, okay? There are conditions for that, and it's fully governed and secured, but it's a mindset, okay? And when observability-driven development tools, dynamic observability, it has many names, becomes part of the tool chain in DevOps, that's when it shifts left and becomes an equal citizen like other tools, Jenkins and the traditional debuggers and other solutions.
It's like you're creating a forum environment, right? Like that's the whole idea, is that I can then relay that maybe a concerned party in that situation can identify someone and relay it to the project manager or whatnot, and then they can decide whether the resources get allocated. I like that idea. Sorry, I'm going to cut you. I don't want to cut you off. It's just this very interesting discussion. It feels like it could actually go on for a lot longer, but we do need to wrap up, of course. We've used plenty of your time. You're a wonderful person to talk to and to listen to. I look forward to hearing more of your work. And if anyone wants to reach out to you, was there details on the final slide at all? Is there somewhere they can reach you?
That's a bug on my end that I didn't provide it in my final slide. I'm definitely available on Slack. I'm on LinkedIn, Eran Kinsbruner. On Google, you can find me with my books and everything. So if you want to find Eran Kinsbruner, there's only one, I promise you. So either lightrun.com, Slack, or LinkedIn, and I will be happy to continue the discussion with you guys later.
All right, hit him up, guys. Pick his brain. He's definitely got plenty of information in there that you would definitely benefit from. But Eran, it's been a pleasure. Thank you very much. The show must go on, so I'll let you go.
Good luck. Pleasure is mine. Thank you so much.
This is all we got. Remember the revolution in our minds. This is all we got.
Lock me out of this life institution. I am angry and I on illusions. Yes, I hate, but it's not a solution. Try my best, but I'm just a human. Oh, we don't need to say we're sorry.